Today we're going to start a series of methods of separating things. And we're going to be taking a look at how to separate two different liquids. We're going to be taking a look at how to separate two different solids, and how do you separate a solid and a liquid. So those are three different separation techniques, and we're going to focus on one technique that's called distillation. You might have heard of a distillery, and a distillery is where alcohol is purified, and it's distilled to make a higher concentration of alcohol. That's where this word comes from, and it comes from the distillation process. So we'll get to the actual name of this, but I first want to imagine that you have a combination of alcohol and water. Let's just say it's rubbing alcohol, because I think that's what we're going to be using in our lab. So you have some form of rubbing alcohol, and a lot of the alcohols, they have a boiling point of around 80 degrees Celsius. So I'm going to put BP for boiling point equals 80 degrees Celsius. Now we're going to mix in alcohol and water. So water has a boiling point, if you remember, of 100 degrees Celsius. And what we are going to try to do is we're going to have the alcohol and water together as a mixture, and we're going to try to separate them. And that's what distillation is. It separates liquids by their boiling points. So it separates liquids by their boiling points. Okay, so down below, I'm going to draw a little bit of this process. Imagine that you have a flask, and this flask is filled with the alcohol and water mixture. Okay, so in here is our liquid, and we have both water and alcohol. And we want to separate those two substances into their purified forms. The way that we're going to do this is we're going to heat this flask, and we're going to try to get the vapors to boil off. So imagine this is going to be a hot plate right here. So here is going to be some heat coming up from a stove or a hot plate or some type of fire burner. And imagine that right now it's at room temperature. So we're going to create a little chart here. So it's 20 degrees Celsius. This is room temperature. And we're going to see which of the substances is going to be boiling. So we're at room temperature. The boiling point for alcohol is 80. The boiling point for water is 100. Okay, if you set a mixture of water and alcohol at room temperature, is it going to be boiling? The answer is no, because we haven't added enough heat yet to get to either of these boiling points. So at 20 degrees Celsius, neither the alcohol nor the water is at the boiling point. So let's create a little chart here. The boiling, and here we're going to have temperature. We'll just abbreviate. Let's bump it up to 40 degrees Celsius. Okay, is it hot enough yet to get either of these to boil yet? The answer is no. So neither the alcohol nor the water will be boiling at this point in time. Let's bump it up another 20 degrees. So we're at 60 degrees Celsius. We're adding lots of heat now. However, we still have not reached a boiling point. So neither of them is going to be boiling. But now at 80, something is going to be happening at 80 degrees Celsius. one of my substances is going to begin to boil. Which of those substances begins to boil? We've reached the boiling point of the alcohol, and so at this point, the alcohol begins to boil off. So the alcohol boils first. And if we keep it at 80 degrees, what's going to happen is all of my alcohol vapors, what's going to happen to all my alcohol vapors? All my alcohol vapors are going to evaporate and then disperse into the room. Guess what I'll be left with down in the bottom after all of the water, all of the alcohol evaporates? I will be left with pure water because I boiled off all of the alcohol at 80 degrees Celsius. So I've now separated my alcohol from my water. My water is now pure in the bottom of my flask because I haven't reached yet the boiling point of water. However, I lost all my alcohol. It went up into the air, it went into the room, it left as a gas, it left as vapors, it boiled away, there's no alcohol left. So I want to try to devise a way of catching that alcohol. And this is the distillation process. So what we're going to do is we're going to put a rubber stopper on top of this with a small hole in the rubber stopper. So if you can draw this hole going down, and if you can draw this, which is going to be the rubber stopper going down into the flask. There's the rubber stopper. There's going to be some glass tubing that comes down through this, and this is then going to bend over. It's going to be a bent piece of glass tubing. And this is then going to connect to a special device called a condenser. And I will show you in the lab what a condenser looks like. And this tubing connects all the way through the condenser like this. And surrounding this inner tube is going to be a larger glass container. Okay, it's like a cylinder. Okay, and it looks a little bit like this. And there are these two stems that stick off of this cylinder. One's on the bottom like this, and the other one is on the top like this. So what happens is this is connected to some rubber tubing. This is also going to be connected to some rubber tubing. And what we do is we fill this chamber on the inside with cold water. So this is what's going to happen now. If we reach 80 degrees Celsius, the alcohol is going to begin to evaporate. It's then going to go up this glass tubing. It's going to continue along the glass tubing, then it's going to hit this area right here, which is called the condenser. It's going to make the gas condense. So your alcohol gases come up the glass tubing and they enter into the condenser, and this cold water is swirling around this hot glass tube in the middle that has the hot gases. And what's going to happen is it's going to absorb the heat from the hot gases, and the water that's surrounding this comes in cool. It's going to absorb the heat because heat's going to transfer from the inner tube to the surrounding water, and what's going to leave is going to be warm water. This is going to be coming from the sink. This is just going to go down the drain. So cold water is coming from the sink. The warm water is just going to be disposed of down the drain. It doesn't have anything in it except for the heat. So what's going to happen again is the alcohol is going to travel up the glass tube. It then encounters this condenser. The condenser has cold water flushing through it. And then it absorbs the heat from the hot alcohol gases, and it cools the alcohol down to a temperature where it's going to condense. And what's going to happen is drips will begin to come out of this, and then you can collect the alcohol. So we will then start with the alcohol and the water, and what we're going to be left with at 80 degrees is going to be the alcohol will leave, and we'll be able to collect the alcohol. No longer will we have the alcohol over here because it will all have evaporated away, and we'll be left with the water. So this is called a distillation apparatus by using a condenser, and it separates the liquids by their boiling points. We reach the boiling point of the alcohol first, and the vapors go up the tube, hits the condenser. The cool water causes the gas to condense back to a liquid, and then your liquid will drip down and you can collect it in some type of container. So here's a summary of this distillation process, and then we'll have a lab which will show this as well. We first heat the mixture, okay, and then what happens is it begins to boil. And not both substances begin to boil, but only one of the substances begins to boil. So one substance with the lower boiling point boils. I'm going to just draw over here. After the substance boils, we collect the gas in the condenser. So we collect the gases, and then those gases in the condenser are going to then condense. So we have to cool this gas. And after the gas cools, it's going to condense this gas. Condense the gas to a liquid. So that's the distillation process, and hopefully you'll be able to understand that better when we see this apparatus in motion.